So, my name's Alex. That was just an excerpt from a video made from an hour rave in Amsterdam, just to give you an idea of the sort of atmosphere. So people writing code, people dancing to it, projections everywhere with code. This feeling sort of immersive in a technical environment and visual environment. So, yeah, sort of similar to a lot of live coders. Sort of work on the principles of a programmer as being a human being, coders being artistic expression, being against autonomy. So a lot of generative music and a lot of sort of discussion around computational creativity kind of forgets that there is a programmer making the software. And people, if you show a computer generating music, they think the computer's generating music rather than someone telling the computer what to do. So I'm against that idea of, not really against it, but in terms of my practice, I really don't want to make autonomous music. I want to make my music. I want to connect with people, so I'm a computer programmer since a young age, and it's quite lonely, and I want to sort of don't actually touch you, but I want to be able to have some kind of experience. No, not too close. Well, yeah, if you want to know more about the, well, you already know about live coding. Yeah, so I tend to do blank slate live coding, not always, but most of the time. So trying to look at any preconceived ideas, going from scratch. Of course, you always have ideas and do this performances, but I like to just come up with code on the fly with different people. In time as well, so just in time programming is something that Julia Rohrer came up with. And so just in time here is actually being in time yourself while you're programming. And having immediate interaction with others through code changes. So you're writing software for the present moment and then throwing it away afterwards, sort of there. Writing code with no end product, it's just about the experience of now and staying with people and so on. And this is where functional programming comes in. It's trying to find languages which are expressive, terse, with close domain mapping. Functional programming is one solution to that. And for me, the ability to understand the code is much more important than, less important, the ability to change it. So quite often I end up with this huge bit of code and it's really messy, but as long as I can still change it, then I can still work with it as a musical material. And it's a bit different from software engineering. There's no need for test-driven, no time for test-driven development or anything like that. And there's lots of functional programming languages. For live coding, I think most of the live coding environments are functional in quite a major way, which is interesting. So, how I got into Tidal, or towards Tidal, quite a long timeline. In 2000, turn of the century, started making music with the aim to, writing code with the aim to make people dance to the code. With my friend Adrian Ward, I wrote a lot of Perl scripts. Adrian wrote a lot of Perl, C and Real Basic. And it took us just over a year to get the first group of people dancing to our code. And that's kind of our aim of completing and ever since it's just been wondering what I'm doing, really. And we got involved in software art, so putting forward the idea of code as being an artistic medium. But then live coding became first wave of live coding came around 2004. We sort of joined that, and yeah, Dave Griffiths joined. He's another sort of scheme person. There's Dave. So yeah, me and Dave were performing in Argus, and afterwards someone came up to us and said, "Oh, you should come to this ICFP event and show your functional programming languages," because he was totally amazed that here's a sort of scheme-based language and there's a Haskell-based language. He found it completely strange that they were both on the same stage at the same time. Is that strange to you? I thought it was completely normal. Normally, apparently these languages, people don't talk to each other at all. I don't know. I found that interesting anyway, because we're sort of making music together with these languages, and apparently there's some kind of divide between these languages. Maybe it's not at all. It's very simple for us. So yeah, so I've developed Tidal through lots of performances, fully improvised. I've collaborated with lots of people, mainly to make broken techno or free jazz. That's led. This is a collaboration with the choreographer Kate Sikio, really interested in live choreography, and so we work together to create feedback loops to our different notations. Matthew U. King, old school drum and bass producer, and he plays drums, generates patterns which I manipulate. Shelley joining us there as well. Is it that Algrave? Yeah, with live artists, banjo players. Oh, there's the Algrave. And of course, with Algravers themselves, people who dance. It's amazing actually. This experience of writing code and having people dance to it incredibly. It's like completely focused on this very linguistic medium, and yet you have this very physical thing coming back. And it's quite a special feeling really, and there aren't many people who experience it, maybe me and Sam and a few others. It's yeah, something which more people should try and do, I think. Anyway, what have I done 5 minutes ago? That's good to do. That sort of preamble. So Tidal sort of is a bit like this. So you have this handle, turn it, and then this rhythm comes out. But you mess around inside this, so you get different kinds of rhythms. And the basic idea is this cyclic sort of function of time, and discrete results come out. I just found this sort of mechanical instrument in the museum. So time is rational. Time is infinite, of course, we all know that. All the time in the world. Time is actually the most common noun. I don't know how many people do that in the English language, but that's an aside. So it's cyclic in that it has a period of one. It's kind of more like a spiral, because time obviously goes forward, but you also have this repeating structure. Mind you, polyrhythm works fine, it's just that you always focus on one period. You can have lots of different things on top of each other. So, based around the idea of an arc as a time range, having a start and a stop, and an event, which is a value which is active within its own arc. This is the actual thing. Time's rational, an arc is 2 times, start and stop. An event has an arc and a value. There's 2 arcs for reasons of, if you drop off an event, it's still helpful to know what the original extent of the event was. But really, just think of it as being 1 arc there. And a pattern is a function from an arc to a series of events. So here's the arc that's input, and these are the events that are output. So they've each got their own start and end, they can overlap. So I went through lots of iterations to get to this, over many years actually, thinking very hard. It's kind of amazing how much time I've put into these 4 lines of code actually. Astonishing. Try not to think about it too much. But, yeah, I find this. So obviously there's a link here with functional reactive programming. I should say I'm not a trained musician or computer scientist, so I don't really understand these papers when I look at them, but I really like this idea of music being a function of time. It's just really natural. But I found that once I moved from discrete time to rational time, I couldn't just have a function of time anymore. As far as I could see, I had to deal with ranges of time, otherwise where would I find the events? They were really small, or maybe that's something I can talk to someone who knows about FRP with. So let's have a look at how some basic building blocks in Tidal are built up. These aren't things that I'd use during a performance. Well, I'd use them, but I wouldn't write anything like this in a performance. But so here's what silence looks like, just a function from anything to nothing. Yeah, there we go, silence. And so a pure event is just one that lasts one period. And there's one every cycle. That's one cycle, and there's one every cycle. So a pure bass drum would be one bass drum lasting the whole of a cycle, and one every cycle. Like that. So, yeah. I've got a pure string, and I'm using this sound thing, which I'll explain later, and passing it to the scheduler, which is then triggering it. It'll just keep going forever. So how this, I mean, part of the reason that it's good to use functions for time is that you can manipulate time separate from the actual values. So the problem is you've got two lots of time. There's the time that you're querying and the time of the events. So you always have to manipulate both. So you have to deal with the queries and the results. So to shift time, you have to add a value, the query, that you're asking for, and you get some arcs back, and then you have to shift them back. And that's just a way of moving time, really. And shifting time in the opposite direction is, yeah, self-explanatory. And compressing time is similar. Multiply to get more events, and then divide to then fit them back into the arc which you queried in the first place. So here's a visual pattern, pure red, pure blue, and I've increased the density, which means that in this one cycle that's been visualized here, you can see red, blue, red, blue. That's not particularly surprising. Density gap is similar, but it leaves a gap when it increases that. So now there's red, blue, then nothing. If I increase the density of that pattern, you see that the next cycle is the same. Red, blue, gap. If anyone has a question, if any of this is unclear, then please let me know. So then to compress each cycle into a particular part of that cycle, you do that in relation to density gap and shift. So you're just squeezing it and then shifting it to where you want it to start. So yeah, instead of being here, it's being shifted into between a quarter and a. Of course, this is rational, so I should really say, yeah, that sort of thing. A quarter and a half. So yeah, and then merging two patterns, different ways of doing that. So I can overlay them so they're happening at the same time. So this is time in this direction, and this is just stacking them up so they're happening at the same time. And so with what I've got so far, I can now concatenate two or more patterns, which is what I've been using all along, using cat to take pure red and pure blue and concatenate them. And if they're different lengths, that's fine. You just have red, blue, green, orange, purple. Yeah, so that's all fine, but it's a bit fiddly to type, so I've got a little parser within parsec, which allows me to very quickly find these things. I've got green, yellow. Yeah, maybe I'll start a bit simpler. So that's just like counting them together. Increase the density so I can see more than one cycle. And then I can take that event and say have green, purple and blue happen at the same time. So it's like there's three events, or three elements in this pattern, red and then orange, and this is broken down into blue and then this sub-pattern, green and purple. So basically you can keep to any level of depth. You can keep adding, just breaking things up. I'm running out of colours. Tomato, I think is actually colour. Yeah, okay. And times 16 just means increase the density by 16. So you see 16 repetitions inside one. Oh, and you don't have to specify a P because of GXG's handy string overloading. It infers that you're making a pattern.
Sorry, Alex, in all of these strings that kind of sub-language, you could write that as Haskell as well, but it would just be longer.
Yeah. So if you can save a couple of characters and reduce cognitive load in any way, then there's a big win for that. So yeah.
But conceptually, just a shortcut to the Haskell.
Yeah. So it's written in parsec, and each one of these things will quite straightforwardly map to some function or other. So density here, this is cat, this is silence, this little pill, so on. There's different kinds of polyrhythms. So here we've got red, black against blue, orange, green. Here you can see they line up nicely. If I instead use curly brackets, then you can see you get more of what you think of a polyrhythm, which is you increase the, the cycle length is still here, but actually this one's shifting.
Polymetric.
Yeah, it's polymetric. You can just see what it's doing, can't you? Oh yeah. So recently I added a bit of randomness, so now you can do things like add, well, so if I have 128 white things, you can't see them because they're white. Then if I say degrade, that'll randomly cut out some of those. You get a barcode, some 18s or something. And again, there's a little bit of, you can just put a question mark after that number to say, or to say, and that's still a function of time, so it's doing, it's not even seeded or anything, it's just, an arbitrary mapping from time using some kind of twist or other. So you can do some quite complex things, even inside this little DSL within a DSL. So a pattern is a functor, which means that you can map over a pattern, blend blue-black with red, and you get pink and red. And it's an applicative functor, which means that you can replace that with a pattern as well, using the applicative stuff. So you've got blue, orange, yellow, grey, spell it by 16, and then blended with white, blue, black, red. You see white, blue, black, red. I've made this all for making music with, but it's much easier talking over a PDF than it is sound, so I'm not using the sound example so far. There is a monad defined, but I haven't really found a use for it yet. I think it's, yeah, applicant seems to be as far as I need to go for this. So, yeah, in terms of time, I find it really nice to have this infinite timeline, but to treat things as cyclic, because you can do things like reverse things without. You can't reverse infinite things, but you can reverse things when they're cut into discrete chunks. So blue, grey, orange becomes orange, grey, blue. But then things get more interesting when it's higher order. So you can say every third repetition reverse. You can't see that because you can only see the first cycle. So I just increase the density again. You can see every third repetition is reversed. Or every fourth repetition shift by a third, in that case. And so on. This is visualizing it in a grid. This is similar when the modulo of 6 is less than 3 or something. I think that means when that means, yeah, similar to every, but you're doing modulos. Iter is quite nice, so I've been at blue, green, purple, orange, and it's just iterating through, shifting it each time. So blue, green, purple, orange, and shifts it to green, purple, orange, blue, and so on until it gets back to the start again. How am I doing with the time? I can't remember when I started. 4 questions. Okay. It's alright. I can superimpose things. I can add. Yeah, basically combining very simple transformations, you very quickly get quite complex structures. And so I use this to make music. Here's an example. Yeah, a bit of clipping there, but so you can see there's, well, a simpler example is taking a sound like bass and snare. So I've combined one pattern with another. So now I've got patterns of hashes. This is sort of the key, and this is a value, and I can just combine those just by doing applicative step to make a new hash. So I'm basically making a pattern of synthesizer messages with it described as a hash. And I can treat these independently, so slow that down by 3. I've got quite a few of these different things I can adjust. What's quite nice is being able to apply a function just in one speaker, so I can reverse this. So juxtapose. And I do that quite a lot. I can do random synthesis, so I can take Leslie Craven and chop the voice into bits. So I find actually melody being very difficult, and probably the opposite of some earlier presenters, and find rhythm really easy. Just trigger lots of drums, it's fine. But maybe that's a different idea. I mean, I don't have any musical training, as I said, so this is all based on, not really, it's all, I don't think it is being practice-based research, but it's research and practice informed by each other. So everything I change, I test through a performance, and then performances will influence what I do. I've done some really bad performances because things haven't worked out. I just have to live with that. It's free software. You can get it here. I think that's me for time anyway. So, thank you very much.
I have I think I found it mind-blowing how you made it even more visual, and perhaps this ties into the comments to the talk before about connections with diagrams, and I mean that really made it. And I think my question is whether there are more things that you can, or you think you could take from layouts, from the layouts paradigm, like I don't know, just to say something stupid, but you know, padding, and it looks like we're keeping using stretching and alignment and synchronization, and that's something that in layouts at least is kind of used quite a bit. I'm wondering whether it's fertile cross-pollination there or maybe not. I don't know.
What layout of code do you?
No, I mean actual two-dimensional layout, say, of tables or elements on a web page, or say.
Well, I can demo an system I've got, which doesn't work very well. But this is an editor for Tidal, which doesn't work, but I can demo with it. It's fine. So this is where things connect based on proximity. So this is trying to.
Do you have cowbell?
More cowbell.
Cowbell. Yeah, most stupid editor Haskell you've ever seen. I'm trying to make something which could be used where syntax. Yeah, I mean, obviously Haskell is quite strongly typed, so it's quite easy to decide what things can connect. So this is an attempt to make something where it takes advantage of that by making those connections automatically based on where they are. So yeah. I can move that here, and it will just kind of decide.
So, more questions? Maybe a slightly boring question to do with the Haskell and the syntax and live programming. So, you're kind of stepping through and evaluating expressions. Is it like a template Haskell thing, or is there some other process of it?
No, so it's just running GHCI and pasting bits. So when you saw bit flash, it was just finding a block separated by spaces and just putting that in the record.
Does it put everything that's sort of gone before it, or
no?
It's just that sort of expression.
Yeah, just where my point is, where the cursor is. So I'm in there and I do Control E. Yeah.
So if I wanted to write some functions and then use them, would I sort of highlight all of that and then say %G?
That's right, yeah. So basically there is some state in that it's got a mutable variable containing a pattern, which is then used to generate. But those patterns themselves will stay for time.
I had a question regarding the definition of the origin pattern types. I didn't really understand why you needed to generate events based on an arc. Maybe you could show the definition again. So essentially, it will generate all patterns between 0 and 1, and everything that goes outside that range is ignored, or am I misunderstanding?
Time is always going upwards, so it starts off at 0, I think. It keeps going through the performance.
Oh.
So it's not just playing the first cycle, it's just keeps going. So when you replace the pattern, if it's up to the 1000 cycle at the next faster, 1001. I think it actually renders in maybe at the moment and then cycles at a time actually.
Okay. So the cyclic nature comes from the actual combinations it generates. All the default patterns are cyclic by default. So you can use density and things like that.
Yeah, which is kind of a basis for doing time functions in the cycle.
Right, I think we need to move on, so let's thank Alex again.